Okay, kids, the time is now to go over question number 4, which is an area and volume problem. You can download the question from Schoology, or you can just pause the video right now and take a look at what we're going to talk about. So right now we're going through finding the volume of R. So I have two functions, y equals 2x and y equals x squared. So this top function right here is y equals 2x, and this bottom function right here is y equals x squared. And we can see that 2x is always on top of x squared throughout. So the first question is A, I want to find the area of R. So what we're going to do is I'll do part A right here, and we're going to set up an integral. So it's going to be the integral of top minus bottom. And in this case, it's going to be dx, because if I draw in my rectangle is going to be perpendicular to the x-axis. So that rectangle right there is going to be perpendicular to x. So if I think about my bounds are going to be from 0, which is an x value, to 2. So this integral is going to be 0 to 2 of 2x minus x squared dx. And then what we want to do is we want to actually find this. Now, if you notice, no calculator. So going through, just perform the fundamental theorem. I get x squared minus 1/3 x cubed, and I want to take this and evaluate it from 0 to 2. So plugging in 2, I get 2 squared minus 1/3 times 2 cubed, minus, when I plug in 0, I am just going to get 0. So that's 4 minus and 8/3. So I could leave my answer like this, or I know that 4 is 12/3 minus an 8/3. I could write it as a fraction. So that was part A, just kind of going through finding the area, the basics, top minus bottom, remembering the bounds. All right, so for part B, I know the region R is the base of a solid. For this solid at each x, the cross section perpendicular to the x-axis, so that tells me that we are dealing with dx, has an area of a of x, and I want to find the volume of that solid. So this is using cross sections. So what I'll do is I will do part B up here. Okay, I'll do a different color just so we can follow through. So part B I'll do in red. And what I need to remember is that this is the integral of the area of a cross section. Okay, so in this case, it's going to be the integral of a of x dx, because I'm perpendicular to the x-axis, and my bounds are going to be, again, from 0 to 2, which are my x values. A of x, it says, is the integral from 0 to 2 of sine of pi over 2 x dx. Now again, without a calculator, we're going to have to solve this. So let's see if we can go through and solve this out. Okay, so as you saw, the answer to part B is going to be 4 over pi. So that's part A and part B. Now what I'm going to do is I'm going to clear everything out so we can see and work on part C. So let's just kind of get rid of all this stuff. And now let's work on part C. So if I am looking at part C, I have another solid that has the same base R, so the same region. For this, perpendicular to the y-axis are squares. So one, I know I'm going to be dy, and my integral is going to be the area of a square. So for part C, okay, I got the integral for the area of a square dy, okay, because I'm perpendicular to the y-axis. So one thing to note is that this equation, y equals x squared, I'm going to write it as the square root of y when I plug it in. And then this equation, y equals 2x, I'll write it as x equals y divided by 2. So when I go through, I'm dealing with dy. So my bounds are now going to be my y values. So I'm going from 0 to 4. Area of a square is going to be side squared dy. The side in this case is right minus left. Okay, dy squared from 0 to 4. So I need to write but do not evaluate. So the volume of this solid will be the integral from 0 to 4 of the square root of y minus y over 2 squared dy. And that's it. That's all of number 4 from 2009. Okay, so here is the scoring guidelines for this question. Okay, I'll go through and just explain what they have. So they have the question up top, and then here is part A. So part A, it was scoring as the integrand. Okay, that is the inside part. The antiderivative, okay, which is this part right here. And then, of course, the answer, which we got 4/3. Okay. Part B is going to go through and give the integrand, okay, which we had right here. Now I did a U sub, so they're showing the answer if I wrote everything back in terms of x. So this would be in terms of x, and these are my x bounds. And then, of course, the answer, which we also got 4 over pi. And finally, the last one, here they give you 2 points for the integrand. So 2 points for being in terms of y and right minus left, and then 1 point for the limits, which is those limits. That's it. Any questions, let me know. Send an email or send a remind. See you guys soon, hopefully.